Here we go. Let's work another stoichiometric calculation. Remember stoichiometric calculation, you have to have a balanced equation. We could convince ourselves this is balanced. What's the stoichiometric coefficient associated with the BR2? It is the number 2. What's the stoichiometric coefficient associated with the TiO2? It is the number 3. That's the stoichiometric coefficient. What is the relationship between TiO2 and Br2? Well, you could write it flat like this. You could say that there is 3 moles of TiO2 is equal to 2 moles of Br2. Okay? And then from that, you could get 2 different ratios. How's that? Okay, well, in this particular problem, it's all about it's all about producing a certain amount of O2. And actually there are 2 kind of sets of problems that go along with that. So let's see what I mean by that. It says if 0.143 grams of O2 is produced, and sometimes I'll read it word by word. I'll find my O2 and I will put 0.143 grams. Okay, well, that's not the question. Now, the first question is, what mass of each reactant? What mass of each reactant must have reacted to give you that much O2? So, in other words, question mark grams of TiO2. Okay, that's one problem. I'll call that 1A. And then we have another reactant. Question mark grams of BrF3. I'll call that 1B. Does that make sense? So actually we have 2 questions within that one. And we're going to work those together. And then here in a minute, I'm going to kind of turn you loose and ask you to work them and see if you can get them right. And then I'll show you how to work them. This one says, what mass of each of the other products would be produced along with the O2? So the other products, I got TiF4, question mark grams of TiF4, and also question mark grams of Br2. Okay, I would call that what, 2A and 2B. So those are the problems we're going to work. We're going to work these together, okay, and then I'm going to turn you loose for the other 2 and kind of meet you on the other side in the lecture notes. So, for all of these, if hopefully you're kind of following along in the printed lecture notes. I don't know if you already have these down. Okay, again, you guys should have bought those from the bookstore, so you should have those handy. But we're going to need molar masses for all of this stuff in order to work collectively 1A, 1B, 2A, 2B. For each of those, we're going to need some of this. Okay, so let's go ahead and see what we got. And I'm going to look back in my notes. Oops, get something to mark with. So like I said, we're going to work out the 1A and 1B right now. For all of them, though, we have the O2, the amount is 0.143 grams of O2. Now, for 1A, I think I have them set up this way. Yes. For the 1A, the strategy, does this look right? I know it's over here on the right, but actually that's going to be the first term we start with. So I'm going to start with 0.143 grams of O2. Always think then to go to moles of O2. How am I going to do that? Using the molar mass. And then I'm going to go, in this case, now to moles of TiO2. How am I going to do that? I'm going to use stoichiometric ratio. And then I'm going to go from moles of TiO2 to grams of TiO2. And how am I going to do that? Using the molar mass of TiO2. That's it. We kind of have that pattern going on. So let's do it. Okay, so that was what was given. That was the mass of O2 produced, and we're going to see how much TiO2 I would need to make that happen. So I need to go from grams to moles before I can use the stoichiometric ratio. So what does the next term look like? Well, a few slides ago we had the molar mass of O2 is 32.00, but we need to use a flipped version of that. 1 mole of O2 over 32.00 grams of O2. That way grams will cancel. Now I have moles of O2. What does my heart, my stoichiometric ratio, look like? There's your hint. So the numbers that go here, I'm liking 3 to go down here and 3 to go right there. Does that make sense? That's my stoichiometric ratio. Okay? I did that now, that moles of O2 will cancel. Now I'm kind of getting to the end of my calculation. I'm ready to go now to grams of TiO2 from moles. I need to use TiO2's molar mass. What does that look like? Hopefully you said something like this. The non-flipped version of the molar mass of TiO2. And all of these stoichiometric calculations have this pattern. That way moles of TiO2 cancel. I'm left with grams of TiO2. I need to round to how many sig figs? 3 sig figs, because of the 3 sig figs in the first term. Whew. All right, let's take a look at the next one. Now the next one, the 1b, so to speak, we are going from, again, the 0.143 grams of O2, and now we're going to question mark grams of BrF3. So the first term is going to be that 0.143 grams of O2 over 1. What's the next term look like? Well, it's the same as the second term in the previous problem. 1 mole of O2 over 32.00 grams of O2. It's the molar mass of O2, flipped version of molar mass. My favorite part now is going from moles to moles. I like this. So again, what I usually do, what does the next term look like? I usually put moles of O2 down here, and I'll put moles of BrF3 up there. To me, that helps because then I go and I pick off a 3 down here, and I pick up a 4 right there. Okay? Now, students, I don't know, for whatever reason, sometimes they don't want to use the stoichiometric coefficients in the ratio, but that's what you use in the ratio. Okay? So now this way my moles of O2 cancel. I'm left with moles of BrF3, and I'm almost there. One thing, I don't know how to say this or point this out, but we know in order to go from moles to grams, we use what? The molar mass of the compound or the element or whatever. Now, this molar mass, I'm going to put it this way since I've seen so much of this with students. This is independent of your coefficient. When I say coefficient, I also mean stoichiometric coefficient. I don't know why. Sometimes I say we, but I don't think I do that. It's independent of the coefficient. So a few slides ago we had the molar mass of BrF3. You're going to have to show that somewhere. That was that 136.90. That would be grams of BrF3 per 1 mole of BrF3. So now moles of BrF3 cancel. We're left with units of grams of BrF3, which is perfect. So now how do we need to round this? I'm liking only 3 sig figs again. Ta-da! Very good. Okay. So I'm going to ask this in the form of the question. You're going to need some scratch paper or whatever. Go off and work this problem and come and tell me what the answer is. So basically we have problem 2A. Okay. 2A is going from that 0.143. Let me double check, make sure I got that right. 0.143, grams of O2, and I want you to go to grams of one of the other products. Grams, question mark grams. It's not a one-stepper, is it? Question mark grams of F4. So question mark grams of this based upon 0.143 grams of this. That's your 2B, sorry, 2A. And then 2B is going to be this one, where I want you to go from 2B, 0.143 grams of O2, and now I want you to go to the other product, B question mark grams of Br2. Okay, so go off in a corner and do those, and go ahead and answer them, what you get. Okay, so here's a check. Is this how you did it? To work 2A, we're going to start with the 0.143 grams of O2. We're going to use the molar mass of O2, the flipped version, so 1 mole of O2 over 32.00 grams of O2, so our grams of O2 will cancel. We need to introduce a stoichiometric ratio. We want moles of O2 to cancel, and we want to be left with moles of TiF4. And then remember that we got this 3 from here, and we got this 3, oh goodness, from here. Okay, now we're ready to knock it out and go ahead and go from moles of TiF4 to grams of TiF4 using its molar mass from a few slides ago, which is 123.87 grams of TiF4 over 1 mole of TiF4. And hopefully you rounded to 3 sig figs, dun dun dun, to give you a mass of TiF4 based upon the mass of O2 produced. They'll also produce 0.554 grams of TiF4. Well, let's take a look at what you did with 2B. So for 2B, you had the same two terms would be the same two terms as 2A, didn't you? So now the stoichiometric ratio is different though. We want moles of O2 to cancel, being left with moles of Br2, so it looks like this. We put 2 moles of Br2 over 3 moles of O2. Both those numbers came from their stoichiometric ratios. Okay, so gonna want to kind of hope that makes sense I hope it makes sense, and that's definitely how you need to do it. The moles of O2 cancel. We have moles of Br2. We need to take it to grams. Of course, to get to grams for moles, we use the molar mass. So we're going to use the non-flipped version of the molar mass of Br2. A few slides ago, you had it 159.80 grams of Br2 per 1 mole of Br2. Hopefully you round to 3 sig figs. Dun, dun, dun. Okay. So this last slide then, this is kind of a unique situation in which you have the mass of everything. You have the mass of both reactants, and you have the mass of all 3 products, and not so surprising, they should be equal. Okay, so actually that's not the way you're going to work problems, but it's a good way to kind of check if you are in this situation where you have the masses of everything.